Good morning, William. Good morning, William. You there?
Hi. Good morning.
How are you doing?
Good. How about you?
Good, thank you. Is your math going okay so far?
Yeah, it's going good.
Okay, good. Okay, so we're gonna begin and we're gonna look at section 1.8, and it should be a nice section and even a quick section. So that's rare. So here we go. Let's see here. So go to your assignment. Okay, so this is we're gonna come back to 1.8. I want to give a little breathing space, so to speak, from section 1.5 and 1.6 before we do 1.7 for those students that are still working on it, and because 1.7 is heavily reliant on 1.5 and 1.6. So in this section is not. So that's why. Okay, so I think the simpler or the best place to start is on number 3 right here. Can you see the WebAssign page?
Yes, sir.
Okay, so I think I'm going to be scribbling here more on this section again today than on my notebook. So, but hopefully no problem. Okay, so it asks us to take a function f, and it just happens to be, it's really a bunch of pieces here like we talked about in the last lesson, but they didn't give us all the equations. They're just saying this one is f, even though it would be 3 pieces. They didn't, that's not the important part of the concept here, is to know what those pieces are, just that they're sitting there. So, and then they give us a second function right here, and they call it the next letter in the alphabet, G. And so we simply have 2 functions in front of us. And now we're going to learn, basically we're going to create a new function out of 2 functions they give us. And they could have asked us to create a new function from using 3 equations or 3 functions or 4, but they are going to just ask us to create a new function, and they don't even ask us to title it, or we can't write the formula down because they didn't give us the formulas of the first 2. In a couple questions later on this assignment, they will give us what f of x is in terms of an equation and what g of x is in terms of an equation. And then they'll ask us to create a new function by performing some mathematical operation. Um, so I'm not going to write all this out. Well, by using or performing, really there's going to be 5 mathematical operations from all the ones that we have. Who knows how many that is, by performing a basic mathematical operation with the 2 functions that's given to us. So by performing a basic mathematical operation, um, on the 2 functions. And using the 2 original functions. Okay, and that takes me a while to write this with this little mouse pen, stylus pen. But I hope it's somewhat readable. Okay, so, such as, and good morning, Griselda.
Good morning.
How are you?
All right. Thank you.
Good. So we're just starting here. And can you see the WebAssign screen with some scribbling there?
Yes.
Okay. So we're on 1.8. We're going to pause on 1.7 to give everyone some time to work on, if they haven't finished, 1.6 and 1.5 and 1.6, because you need that understanding to be well or strong. So for 1.7 to be easier. So that's why I'm waiting. So this section 1.8 is a really nice section. I don't think we'll have, there's really only one somewhat interesting, more advanced little discussion, but other than that, it's really a nice to understand. So, so this section is about creating a new function. Excuse me, if you have two functions or more to begin with. Here they gave us two, f and a g, and they want us to create a new function by using one of the basic mathematical operations. And the basic mathematical operations, what would you guys think are the most basic mathematical operations that we tend to start learning when we're little with numbers, and then we start to do it with functions and so forth? But what are the most basic mathematical operations?
Addition and subtraction.
Addition, good. So I'm just gonna put, okay. So by addition, subtraction, and what would you say most people would say are the next two basic mathematical operations that we tend to learn when we're little?
Multiplication and division.
And the next one? Division, good. So multiplication and division. And then, so that's what a large piece of this section is about. Using those four basic mathematical operations: addition, subtraction, multiplication, and division. And then there's going to be one more that, and this might be a new one, a new mathematical operation that we wouldn't have maybe talked about much yet. And that is called composing. But it's very nice. It's not difficult, I hope. A new mathematical operation called composition. And hopefully, I think this will be about the last major notes here, called or named composition, or I should say composing. So we can create a new function. So we are in a factory and we are going to create new things. And instead of new machines or cars or clothing or whatever, we're creating new functions from two functions that we have to begin with. And we are simply going to do that, creating new functions today by either one of these basic mathematical operations, or this new one called composing. Okay, so one thing we can do is instead of creating the new function as a formula, which we'll do in a few minutes, but to create just the new graph of the new function. So in this particular problem, number 3, they give us the graph of one original function, if you will, and it's called f, this upper one. And then they picked another graph, but instead of giving us the formula, they just gave us the graph. And we're going to perform one of these basic mathematical operations and create a new function. And they're calling the new function h. They just went in alphabetical order. So this is our new function that we are creating. And instead of creating the formula of this new function, that would be, well, it's not impossible. We could figure out all these pieces, but it would be a mess. But all they want us to do on this one is not create the new formula of the new function h, but just the graph of the new function, okay? And all we have to do is we could pick any points on this, but it just makes more sense to pick the ones that are highlighted. These are more of the important points. This is the starting point for f, and this of course is right at x. This is right at x equals 0. So when we combine this graph f and this graph g, and we want to do a graph of the new function, then we just pick some key points and then say, okay, at x equals 0 is where both of them start. So you cannot add like a point at x equals 0 on one graph plus a point at x equals 1 on the other graph. You have to stay with the same x value. So unless they ask a really tricky question, which they're not going to, at least on this section. So all we got to do is make a table, and we could do it mentally or visually as well. And we can say y, but this y is going to be the new function h of x. And so this one's the new one. And so the new function. And so this is supposed to be an x right here. And so remember that h of x equals f of x, and let's just, oops. And I need to be more patient here. That's f of x, well, they tell us that is. And we are going to create a new function by using the basic mathematical operation of addition. So plus g of x. And so we start to pick points here. So what makes sense, guys? What x value did these two graphs start at, of course? What x value?
0.
0. So we should do that. And we simply, to get the new function, we find what's the graph, what's the value of f. So what's the value of the f graph is this one. And Griselda, what's the value or the mapping, the range value at x equals 0 on the f graph, the orange one here?
2.
2. Good. Plus the mapping on, let's say this one's G. I mean, you don't have to color it, of course. But what's the mapping here, Griselda? At x equals 0, does the function G, is it up above, positive number, and below negative, or right at 0 still?
Right at 0, sir.
So then we simply add, and 2 plus 0 is 2, of course. So right here we put 2. Any questions there?
No, sir.
And now we're going to do it for well, I hope it makes sense. The key points would be at x equals 0, and then this one right here at x equals 1, because that's when both of these change. So it makes sense, I hope. The next x value that seems to be significant for us would be x equals 1, and then 2, and then 3. And then it stops. So, okay. So we already have 1 point, and we're going to do 3 more, and then we have it. And again, we could have done this by just visualization, by visually looking at these points. So let's come down here to the new graph. This is where, well, we'll just wait. Let's just finish the rest of them. So William, of course, what's the mapping on the F graph at x equals 1? Because we're going to do that here as well. And so what's this one going to be? At x equals 1, what is it? What's the mapping or the range value on graph F?
0. Oh,
So,
on F, sorry. Or on F or on G?
for an F.
Oh, 3.
3. And then you were correct. You were just looking at the other one. And for G, at
0.
1, x equals 1, it doesn't go up or down. It stays. So it's what still?
0.
0. And 3 plus 0 is 3. And so on. Any questions here?
No, sir.
No, sir.
Okay, Griselda, can you help us with the next one? What's going to be f of 2, the mapping at x equals 2 on the F graph?
Point. Oh no, it would be on the F. It would be 1.
1. And I can barely hear you, Griselda. And the next one for G?
G, it would be 0.5 or half, 0.5.
Yeah, it looks like that. So I think we're just supposed to assume that it's 0.5. And then the 3, Griselda?
The 3 on F is 3 again, and then on G is 3.
So be careful. We want the
Oh
x.
no, it's 2. I'm sorry.
So it's 2. Yeah, we got to remember both dimensions, huh? And the 3 is the x dimension, and then we want to know their mappings, right? So the mapping is the y value or the range value, and you said it was 2. And what's this other one for G at 3?
At 3.
I'm sorry.
3.
So.
Oh no, it's a 0. Okay, I'm getting confused.
It's okay. I get confused every day, and
it would be 0 because we're doing the y, right?
Very good. And now we just add them up. So this is 1.5 and 2. And now we have the key points for the new graph. These you might call, I mean, it's subjective statement, but key points. It's not factual, but I think we can agree that the beginning, the end, these highlighted points, that's why they highlighted them. And okay, so now we connect. So we come down to the graph. And we know, let's see, how are we going to do this? I don't do this often enough, but these, I guess, they're going to be, I think we just put here, and we're going to have little line segments again, and we're going to have pieces. So I would imagine we use this tool instead of one of these other two. And now we start, and the first point is, so right here is x equals 0. And by adding the first function plus the second function, we have created the new mappings to give us the graph of the new function h of x. And now we just plot those points. So 0, 2, and the next one is 1, 3, and there it connected it. So that's what's neat about this WebAssign graphing tool is when you plot the first 2 points, you told it to connect it with a line segment, and that's what it did. Yeah. And by the way, notice this line segment right here is the same one as this one, because it starts up here at 2 and then it goes right up here to 3, and that's exactly what F was. So why did it not change? Because when we added G, what was this part right here for G? What was the mapping right here? It was only, was it positive number, a negative number, or 0?
Just 0.
So yeah, so when you add this piece of f of x plus this part of g of x, since g of x here is 0, well, if you add all this, the 0 to this, it doesn't change. And that's why this first piece didn't change. Okay, and okay. So and now we continue. So what about, oops, what about the next piece will be from the line segment from 1 to 2. And let's see, so what did we have? 1, 3, that's already right here. And now we have 2, 1.5. So, oh, I gotta click this again. 2, now I don't know what's gonna happen here. If it's gonna, I might have to type it in over here. Let's see. I don't know. So the graphing tool is it's sophisticated enough where it knows it was supposed to be 1.5, and then it just kind of helped us out. I believe we could have typed in the points right here as well. So maybe we can also do that on the next one, just for learning this tool. Oh, so what happened here? It didn't connect the two. So why? Oh, maybe, I don't know why. Oh, it's because I made a mistake. I'm so sorry. So I need to delete this one. My mistake, sorry. So this one, this point was, I gotta click this one because it's gonna connect. This is the end of the first segment and it's the beginning of the second one. So I needed to re-click this one. And then the next point was 2, 1.5. And now I can click it right here. And well, that's what I'm doing. So there we go. Any questions there?
No.
No.
Is that okay, Griselda?
Yes, sir.
Okay. And the next line segment will start right here and it'll end at the point 3, 2. And so we click this again. This is the first point, and the second point is right here at 3, 2. And there we go. And I guess you had to click it again to turn it to the color black, I believe. And now we submit. It says segment 1, segment 3, segment 4, because we had a segment 2 and I made a mistake graphing it on this tool and I erased it, so it just skipped it. So it doesn't mean, well, I hope it doesn't. Well, I guess we'll find out. And we're good. Okay. Any questions there?
No, sir.
We're good?
Yes, sir.
Okay, so let's go on. So we're going to continue this creating a new function by using a basic mathematical operation on the two original functions they gave us. And they'll ask us either to add them together, which was this one. We added them. They could say subtract them. They could say multiply them together or divide them. And then there's this fifth one that is, it may or may not be new to us, but it's called composing the two functions together. When you compose, like you create also, that's like a creation, but it's a different kind of a mathematical operation than any of these four. It has you do something differently. Although, I mean, if you just added them, well, that would be back to addition. Or if you just divided them, that would be back to division. So this means a new type of this is a different mathematical operation than these four right here. Okay. So I'm just going to erase this and move down. Oh, number one here. William, can you read this for us?
The two functions f and g can be combined by the arithmetic operations of blank, 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 and blank to create new functions.
That's a lot of blanks, huh?
Yeah.
So, what do you think? Although I don't know how mathematically correct it is to say arithmetic, but well, certainly the first two. So these are like the 1, 2, 3, 4. Hey, we talked about the four basic mathematical operations. I wish they would have said basic, or the first two are arithmetic, but I don't know. I guess you can change, you can think of multiplication as addition as well, I guess. So maybe that's why. So of course, which one of these four did you think they want us to put there, William?
Subtraction, addition, division, and multiplication.
Yeah. And what is the only, what's the fifth one that I said we're going to learn here today that's on this list?
Composition.
Yeah, this one right here. Okay. These other things here is when we move a graph. You take one graph, that's what we did in 1.5, 1.6 a little bit, and we're in 1.7 heavily. We only did this one so far, shifting. We shifted a graph to the left or to the right, and that's when you add or subtract next to the x variable. And yeah, and that's also called a translation. But, and then, oh, here's the new one, as you said, and then reflection. We have talked about reflections already as well. And yeah, so that's what these three are right here. So anyway, so we go on. And that's simple enough. And this one right here, this little strange symbol right here, this little circle right here does not mean multiplication. Multiplication is like a dot, multiplication. So multiplication is when we have a dot, and this one is the fifth one. It's the composition. So multiplication is reserved like as a dot or an elementary. Well, we learn a little cross for multiplication sign. It's perfectly fine. This means the composition mathematical operation. This is when you compose. Composing. And that's what we'll talk about in a few minutes. Okay, so composing, and this means you're going to put the function, whichever one is second. G is written secondly, F is written firstly. These are the two original functions, as I've been mentioning. we have two original functions and we can do something to them, some mathematical operation to them to create a new function. And this is the fifth one we're going to look at today, is the composing one. So when you see this little dot, I mean a circle, empty circle here, that's composing. And then we're going to learn that this is an alternate way to write this and this are equivalent. Yeah, they're just different notations. So this means the inner one is G, and it's saying here, put G of X inside the whatever is written out here, which is F. Put G of X inside the F function, and that's this composing new operation, how we can create a new function. You put one function into another one, and presto, we get a new function. And that's called composing. And then I'm going to show you that in a few minutes. So, okay. So this is not addition, not subtraction, not multiplication. It could be kind of thought as a combining, but they want this one right here, composition. And we're good. Okay, so that was just introductory there, some vocabulary, and going back to what I've already been mentioning. So you all could do this one. I hope it's the same as number 3. And again, create a new function h by taking the two original functions. This one here is the f, this one here is the g, and then adding them up again. And I would suggest, if you wish, make a table like we did on the first problem above it, or you could do it mentally. It's up to you. And now, as I mentioned, see on these two, they didn't give us the formula for f. They didn't say, oh, f of x equals 3x minus 1 or something. And they didn't say, oh, g of x is x squared or something. They just gave us the graphs. And then we created the new one graphically. And now we're going to do the next thing we'll be doing is the same idea, but they're going to give us the formula for f. They're going to give us the formula for g. And then we perform to create a new function. We're going to do either one of the 4 basic mathematical operations, add them together, subtract them, multiply, divide them, or compose them, and create the new function, but as a formula instead of a graph. Well, once you have the formula, we could always graph it, but they're not asking us to graph it, just the new formula. So let me pick something here. And how about number 7? So number 7, so they give us, there's one of the original functions. Here is a second one, and they call one of them f of x and one of them g of x. And now they want us to create a new function by doing something to the two. And actually, these are all 4 of the basic mathematical operations. Add them together, subtract them together, multiply them together, divide them together. Okay, so let's see. How about we start with letter C here, and we will do whatever it says. Now, of course, Griselda, what does this mean right here? FG. There's not even a dot, but we're supposed to know this means what right here?
Multiply.
So multiply f, equation for f, and then times the equation for g, and won't that give us something new?
Yes.
Yeah. So, okay, so this is going to equal for f. What are we going to put here for f, Griselda, of course? What's the f function?
7x plus 1.
And then we're gonna take the second function, which is g, and we're gonna multiply it. So times what then, Griselda?
X squared minus 9.
Okay, and now we just do that. And whatever we get will be our newly created function. Yeah. So let's see, there's two terms here and two terms here, and we just multiply it out. So pretend I'm covering up the 7x, and we're gonna multiply, I'm covering up the plus 1, and we're gonna multiply 7x times these two. That'll give us two terms, two answers, and then we'll be done with the 7x, and then we'll multiply positive 1 times those two, and that'll give us two more terms, so a total of 4 terms. Okay, so Grisela, what's gonna happen when we multiply the 7x? What are we gonna have to multiply 7x by times?
X squared.
Good, and what is that?
X cubed. 7x cubed, I'm sorry.
Good. And then we got to multiply 7x times what else?
Negative 9,
And
which
what's
would
that?
be negative 63x.
Very good. And then, Griselda, are we done?
No, sir. We would proceed with the 1 to be
1
multiplied by
times,
the x squared.
which is?
X squared. Positive.
And oh, yeah,
squared.
plus x squared, positive x squared. And then?
Negative 1 times negative 9, which would end up being still negative 9.
Good. So here are the 4 terms. If any of these are like terms, meaning if this is an x, what do we say this was? X cubed, then if any of these other are x cubes, then we could combine them. Or if this one is an x squared, if any one of these other ones has an x squared, we could combine them. Or if any one of them had an x to the first, like this one, we could combine them. Or if we had a number by itself only, we could combine it with another one that was just a number. But none of these are the same, are they? They're not similar or like terms.
No, sir.
So therefore, we can only leave it like this unless we want to write x cubed first, and then x squared, and then x to the first, and then a 9. That's descending order. You don't have to, but well, we might as well. But let's go ahead and do the other ones first, and then we will input them all at once. So, okay. So let's see. How about this last one? So William, of course, they want us to do what here?
Divide.
And what goes in the numerator?
The 7x plus 1.
And the denominator?
X squared minus 9.
So they don't literally want us to we could divide x squared minus 9 and divide it into 7x plus 1 and get an equivalent answer, but they don't want us to do that. But I do want to mention this. If we can factor anything on the top, if we can factor the bottom or the top, then let's factor it and see what happens. So on this first one, there's an x to the first on the first term here. There are no x's here, so we cannot factor any x's out. Same thing, by the way, down here. There's a multiplied 7, but this is only a 1. So we cannot take a 7 out, well, unless we wanted to write a fraction. But so this we can't factor. So we'll just leave it like that. How about the bottom one? You guys remember when we talked about perfect square? a perfect square number or a perfect square expression? Is x squared a perfect square expression, William?
Yes.
Because what? We can draw a square, or a square exists. Oh, I destroyed my little exponent here too. Because what? You can have a square with area x squared because each side would be what? What would
Equal.
this? I'm sorry.
Equal.
They would have to be equal. Good. And what would it exactly have to be? Would it be like a 3 times 3 or a 4 times 4 or a variable? What would have to be here and here?
X.
X, yeah. And what about 9? Is that a perfect square?
Yeah, it is. Yes, sir.
Because what?
Because each side is 3.
Yeah. So these are both perfect square objects or expression or numbers, whatever you want to call it. And we have a difference of 2 perfect squares, so that always can factor. And so we've talked about this before, but just reminding. So now, William, what has to go? There's 2 terms in this one and 2 terms in this one. So what times what has to give us x squared?
X and X.
Good. How are we going to get negative? What has to go in these 2?
Negative and a positive.
Or the other way around, doesn't matter. And then what times what will give us 9? We have to use what?
The perfect square. 3 and 3.
Yeah. And if we multiplied this out like Griselda did up here with this other problem, we would get back to x squared minus 9, okay? Without going through all that at the moment. So, and the reason I want us to factor is 2 reasons. One is if there was an x minus 3 up here or an x plus 3, we could divide them out. Although that does open up another discussion, but there wasn't. So they don't divide out. So this is done. So that's what we're going to put right here. And because nothing divided out, we could write our answer like this one or the first one, and they're going to accept either one. But there's a reason I want us to factor. I'm just going to hold off about 2 minutes to talk about that. Okay. So any questions, Griselda, any questions here?
No, sir.
Okay. So let's go to, well, let's see. How about the B? So B, we're going to subtract them. So we're going to write what, Griselda? What's F again?
F, oh, I'm sorry, 7x plus 1 minus x squared minus negative 9.
And then we got to remember, if we write this only, x squared minus 9, and we write it just like that, then this subtraction, which we're supposed to do is, are we supposed to just subtract the first term of this second function, Griselda, or do you think it means subtract all the terms in this? So it's
all
F.
the terms.
So is it just saying, oh, you know what? You only have to subtract the first term on the G. Or do you think it means you got to subtract everything?
Everything.
So then that's why we need
You have to put parentheses.
Does that make sense?
Yes.
And that's a common error or typical error that we can make that we want to avoid. So now we can just, 7x plus 1, we can just rewrite it for the moment, for a few seconds here. And now distribute this subtraction sign, because this means subtract both terms. So then it's subtract this, subtract this. Another way you can think of that is negative times this positive x squared and negative times this negative 9, and then we'll write that down. So what's going to be, or you can say, oh, I'm subtracting x squared, and that's the same thing as just writing minus x squared. And then I'm subtracting -9, subtract -9. What's subtract -9 mean? It's, well, this changes to a what?
Positive.
A positive. Or you can think of it as negative times positive was negative x squared, and then negative times -9 plus 9. So yeah, okay. And now we have 1, 2, 3, 4 terms. And let's just get in the habit of writing the final answer in descending order. And so which one, Griselda, here has a variable x and which one's the biggest exponent?
Negative x squared.
And can we combine it with this 7x if it's only to the first power, if we by addition or subtraction, or no?
No.
No. So what are we going to write here? There's nothing in front of this 7x.
We put a positive
Yeah,
7x.
that's good. And then what? What about the last two terms, Griselda?
We are able to add those together.
Yeah. So what's that?
10.
Mhm.
Positive 10.
And there's the answer for part B. And then part A, of course, we're going to do what, William? Add them. So on this one, let's just go faster on this one, William. What's going to happen when you write plus? So 7x plus 1 plus x squared. Well, I can write it down. 7x plus 1. And then plus. And we are adding all of it, of the second function. But after we write this down a few times with addition, we realize that positive, this is like a positive 1. So positive times this positive, that's still going to be what?
A negative.
So what's this positive time? What's positive
sorry.
time? I'm sorry?
I said, oh, sorry. I said it was also be a positive.
Yeah. So we just get positive x squared still plus x squared. And then what's this positive times this negative? 9?
Negative.
So when you're adding the two functions together and you add this second one, even though we are adding not just the first term, but we're also adding the second term of the g. But when you add them, it doesn't change anything here, does it?
No.
Only when you subtract, then it changes, yeah? So anyway, so now what, William, what if we write this in descending order?
X squared plus 7x minus 8.
Good. And now we have these 4 done. So we can input those and hopefully we have it correctly. So okay, so we have x squared and we have and this fraction, you don't need to put the parenthesis up here in the top. If we want to, we can. In the denominator, we could write x squared minus 9. That's fine. We could also write these two. I'm just going to put it with these two because I want to emphasize something that is next. But it's either one they should mark or say as correct. Okay, so all of these are correct. Okay, any questions on that, on creating those new functions by using all 4 basic mathematical operations?
No, sir.
Okay, good. And now this part, the domain. So we do need to talk about this a little bit. So I want to, we've already talked about domain before by looking at a graph. And I'm going to switch to Desmos for a moment and have a little short discussion on a couple ideas. And so let's see. If we graph, so, whatever. X cubed. Oh, I'm sorry. I'm having trouble here, I think. What's going on here? Oh, I know. And then, okay, so, here's a graph. And let me draw the x-axis. That's this blue line, just to highlight it. And if we talk about the domain, when you look at a graph, you just cruise along this first dimension, the x-axis, or we can call it the domain axis. And then we ask ourselves, what numbers on this domain axis are in the domain set or in the domain bag, if you will. And so for example, Griselda, would x equals -4 belong in the domain set or the domain bag? It does, as long as x equals -4 has a mapping. If you go downward or upward, it has a mapping, yeah?
Okay.
So does -4 belong in the domain set then?
Yes, sir.
Yeah, because it maps up to whatever this number is, yeah? So, and we could find out by trying to get this to work or plug it into the equation and it would give it to us. And it's 5.333 repeating, or 5 1/3. So -4 belongs in the domain set. How about how about -6, Griselda? Does that belong in the domain set?
Yes, sir.
Because
It's going down.
yeah,
It's
x equals -6 does have a mapping, and it's down here, huh?
yes.
Yeah. How about, what do you think about -10, Griselda?
It's a possibility, but I'm not 100% sure. From the looks of it, it's not. But,
And what do you think? What do you think happens? That's a good question, a good point. What do you think happens to this? Do you think this is gonna, if it gets straighter and straighter, and it doesn't keep going this way, then you're right. Or does it look like it may be slowly, but does it look like eventually it's going to make it? Doesn't it look like this keeps moving over?
yes,
So then what do you think?
it's included.
Yeah. So, and then it just goes down a long, long time before it gets there, huh?
Yeah. So it'll be infinity so far.
So it may not, this does go down to negative infinity, you're right. But at 10, I'm guessing, not guessing, but at negative 10, I bet we don't have to go that far. Even we're at negative 75, but that doesn't compare to negative infinity, does it? Yeah.
Mm-mm.
So if I back up, zoom out here, so this right here is negative 10 still. It does touch it somewhere around here, doesn't it?
Yes.
And it's not, even though negative 100 to negative 120 is quite a ways down on the x-axis, but it's nothing compared to forever, is it?
Correct.
Yeah. So it kind of depends on our perspective. Even negative 60, yeah, it looks like it's going to take a long, long time for this graph to come over to here, but eventually it will. Does that make sense? It's kind of hard to tell here, but it all depends on the perspective. But without taking too long on the discussion, I hope this just keeps moving over this way, but kind of slowly, but it does. So eventually it will, at negative 60, we'll just have to go wait. Like if I change the perspective, which means the scaling, then you'll see it differently. So let's say I make this like 1900 and make this 2700. So now it's more obvious. Well, even still, I'd have to go a little bit more here. Maybe I make this a 5,000. Oops. 5 and a 2. And yeah. Oh, I went the wrong way anyway. Sorry. Okay. So at negative 60, now you might say, Griselda, oh, it doesn't take that long. It does hit. But look at it's way going to be way over here at how far down? Negative what? 35,000. And the way I had this scaled, Desmos was scaled, it would have taken forever for us to move down to 35,000. If we change the perspective, the scaling, then it doesn't take that long. It doesn't seem that long as after all. So it just depends on how we call all these scales here, all these little boxes, what they're worth. Does that make sense?
Yes, sir.
And I can't hear you very well again, just so you know.
Okay.
So what do you think then, Griselda? The domain of this function, what do you think? You think there's any x values if we keep going this way? You think eventually it's going to go down and touch the graph?
Yes.
Yeah. So what would we say the domain set is for this one? Yeah.
Negative infinity
Good.
all the way to positive infinity.
Excellent. The domain would be, depends how we write it, but in interval notation, negative infinity to positive infinity. Very good. So every single one of these x values, which is on the domain axis, are in the domain set. Yeah, all of them. Is that okay?
Yes.
Okay. Another thing, and you see right up here in this equation, was there anything like for example, if we would put a 4 over x right here, now that would change, well, of course, anytime you make a change on the equation, it's going to change the graph. But see here, there was no division with an x, the variable x in the denominator, or neither here or neither here. But if we put one there, well, anytime you change anything, it's going to change the graph. But this is going to change something in kind of important. And let's see here. And let me do this. What if I even make it x? We make it x plus 5 or 4. Okay, 5. See, now something's going to change in the domain because when you divide by something with the variable in the bottom, then that makes the possibility that there's going to be at least one number on the domain axis here that won't have a mapping anymore. It won't have a range value. So, so there's a couple ways we can talk about that. But so remember this, guys. I kind of mentioned, we kind of mentioned this discussion. We had this discussion before. 12 divided by 3, we know that's equal to what?
4.
4. And then someone, some smarty says, hey, William, prove it. And you would be, well, it is. It just is. Or you could say, prove it. Why? Because the 4 times the what, William?
The 3.
Equals what?
12.
Yeah. That's why, smarty pants. Okay, we would say. And now what if we had something like this? 12, let's say, oh, it doesn't have to be a 12, but what if we said 0 divided by 4?
0.
What would we say here then, William?
0.
0. And then someone says, prove it. Why? Why is the answer 0, William? How could you prove it?
Because 0 times 4 equals 0.
Yeah, this answer, our quotient, times this number down here, the divisor, 0 times 4 gets back to this numerator. And so, yes, this is correct. And same up here, yes. So this is leading up to a point. And now, what if we ask this question? What if we said 7, nothing, no special reason why I said 7, but 7 divided by 0. So, William, what do you think about that one?
It's
gonna be 0.
impossible.
So someone said 0 and someone said impossible. I'm going to go with 0 because I think that person's right. Okay. I could be wrong though. Why? Prove it. Prove it, pal. And what would we have to do to prove it, William?
0 times 7.
Well now that would do it. 0 times 7. But are we supposed to multiply this answer, this quotient, times this one on the top or times the one on the bottom?
Oh. Then just 0 times 0.
Yeah. So what do we get here? Because 0 times 0 equals 7. There you go. Or is that false?
False.
False. So what does that tell us, William? 7 divided by 0, does it equal 0? Is that true or false?
True.
It does equal 0?
0
Well,
times 0?
Huh?
0 times 0?
So, no. What is 7 divided by 0, this original problem right here, does it really equal 0 or is that incorrect?
I think it does equal 0.
Okay. And then we said, prove it, William. And how do we prove it? We have to say this number times this number has to equal this one up on top.
Okay.
Just like 12 divided by 3 is 4. Why? Because the answer times this number underneath, the divisor, would have to get back to 12, which is called the dividend. But anyway, and 4 times 3 is 12. So yes, the answer 4 was correct. So this is correct or true. And what about the one underneath here? 0 divided by 4 equals 0. And then we said, is that correct? and it's either true or false or yes or no. And what did we check? To check, you take the answer, times the divisor, and you have to get back up to this. Well, what is 0 times 4, William? What does that equal? 0 times 4 does equal what?
0.
So this was correct, wasn't it?
Yes.
Now what about this one? 7 divided by 0, is that 0? True, false, correct, incorrect? Well, if it's 0, and if 0 is correct, then when we multiply 0 times 0, we have to get back up to this number on top. Did we?
No.
Because what is 0 times 0 going to be?
0.
0. And we're supposed, if this is correct, we're supposed to get 7. So this didn't work, did it?
No.
That means 0 is what then? Correct or incorrect?
Incorrect.
Ah. So 7 divided by 0 is not 0. Is that okay?
Yes, sir.
And it kind of goes against our intuition a little bit. Yeah? So then what does it equal? If it's not 0, well, then it must be some other number. So I don't know. What do you think, William? Could we put, you think we can put any number here? Will any number be correct here? Is it possible that 7 divided by 0 will equal any number?
No.
Well, there's a lot of numbers out there, William. Yeah? But why do you think it won't be any number there?
Because 0 times 0 will always equal 0.
Ah,
Number 7.
well, never perfectly said. Yeah? No matter what number we put here and then we check it and multiply times this one, that's always going to be what?
0.
And then we're never going to be able to get back to 7, are we?
Correct.
Correct. Excellent. So that means what? 7 divided by 0, does it equal any number at all?
No.
No. No such defined number. Never. It's not, there is no defined number we can put there as the answer. And if once we know that, then the discussion that is next will be easier for us to answer. And unfortunately for a lot of people that learn these topics, if they don't learn this part first, then they're always kind of lost about what we're about to say next. Okay? So if someone wrote down someone walks up to you in the parking lot and they say, what's 7 divided by 0? What are you going to tell them?
No solution.
You could say no solution. Okay. What else do you think you could say?
It's impossible.
It's impossible. That's correct. What else?
No such defined number.
Ah, very good. And what do you think is the most popular response in authors' textbooks or when teachers are trying to say, hey, what's this equal? None of those answers, well, maybe, none of those you said probably is the most popular, but they all are correct, what you said. I actually like this one best. Okay? Mm-hmm. That's just my opinion. But the most popular is when you say no such defined number, the most popular will be to say it's an undefined it's an undefined, and they just say undefined.
Okay.
Or they'll say an undefined number. Well, that means that it's not a number. There is no number. There is no number that'll work. So the most popular answer is undefined, or you say it does not exist. I like your answers better, personally. The 3 you gave, I like better than this one, because this is kind of vague. It's understandable once you understand that the 3 things you said are also true. Yeah?
Yeah.
Does that make sense?
Yes, sir.
If we just jump and say it's undefined, we're like, well, what does that mean? Undefined. But I hope it makes sense to you all. Griselda, is that okay?
Yes, sir.
Okay. Thus, now the next part I hope will be easy from now on. And that is, if we just have, well, what about this term? If we change this graph and leave these two the same, but this last term we write 4 over, that's not an absolute value. That's supposed to be a parenthesis. and we say, okay, what's the domain of this graph, of this equation, of this function? And now we gotta be careful, because I see a division in the denominator, there's the variable there. If all it's there is a number, then it doesn't change the domain. And the domain will still be all real numbers, or from negative infinity to infinity, like Griselda said, right here. But as soon as you put a fraction with a variable x in the bottom, oops, now you have opened up the possibility of this happening. Dividing by 0, which you don't get any defined number. Not getting a defined number means there won't be a mapping. Griselda, what if we asked you, or let me just zoom in here. Griselda, what if we asked you, what's the mapping at 20? Well, it's not going to make sense right here, but okay, let me wait. So, okay. So, William, when do you think, what number would we put right here in the bottom for x? And then it will get this kind of situation. It won't be 7 over 0, but it'll be negative 4 over 0. Mm-hmm. That's also going to be the same problem as we have right here. So what number would we put right here for x and end up having in this no such defined number as the answer? What number would we have to put right there for x?
0.
Okay, 0. That's a popular answer. So what happens if we do put 0 right there? What's 0 plus 5?
Oh, 5. Oh, so negative 5.
And then you would get negative 4 over 5. And that's okay, isn't it?
Yeah.
So then you corrected yourself very quickly, and that's good. And then I think from now on, you're going to have it, which is what this discussion was for. And so, okay, so second chance here. So what did you say instead?
Negative 5.
Negative 5. Very good. Because negative 5 plus 5 is what?
0.
And now we have negative 4 divided by 0. Does that equal anything? Is there any answer to negative 4 divided by 0?
No.
No. And don't say 0, right, William?
Right.
Okay. So what do you think that means when we graph this at x equals negative 5? What's going to happen? You're going to get this negative 4 over 0, and then you're looking for a range value to map, but then you're going to say there's no such number. So what do you think will happen now? I'm going to, and I'm just going to type y equals fraction, and we'll say -4. So we're almost there. Divided by x plus 5. And I know this is a mess. I just don't erase it quite yet. I can erase this part though. And so, and I mean a much better window. That's not it. Can I get away with all, I don't know. So maybe there's a way to start this graph over so the, but I don't know. I don't remember how. Okay. So where did we say we were going to have issues here with a division of 0, which means when you are trying to make a table to get points, let's say we're trying to make a table to get points to graph this. Yeah. What number when we put in for x, like if we put a 0 in, we put 0 here, and that's what you said before, and we would get 0 plus 5, which is 5, and then we would have -4/5. That's okay. That's a number. And that's the same thing as -0.8. So if we go to the Desmos and we go to x equals 0, there's a mapping at x equals 0, and it better be what? -0. What? You guys with me? Did I lose the world here?
No, sir.
Hello? Anyone out there?
You can't hear me?
Not barely. Yeah, William, are you there?
He's on mute for some reason.
He's on mute. Yeah. Come on, William. Maybe he took a break. But what should we get for a mapping here, Griselda, at 0? We do get an answer. We do get a number, and it's -4/5 or -0. What?
0.5.
Where did? Oh, this is an 8 right here. Maybe.
Oh,
I'm sorry. So if we go right here, we better get -0.8. You see that?
yes.
So that means what, Griselda? At x equals 0? Does it have a mapping to the graph? Does it have a range value?
Yes.
Yes. So that means x equals 0 is in the domain set, is not in the domain set. What is it?
It is.
Mm-hmm. How about all these other numbers along the x-axis?
Yes, sir.
Yep, except for 1. Why except for 1? Because what is the only, oh, I see a variable in the bottom, in the denominator. And what number would you put right here and have this issue of dividing by 0, which then is no such defined numerical answer? At what x value?
-5 on that one.
Mm-hmm. So if we were to come right here and say, oh, I'm going to get another point at -5. If I can write a number right here, well, then -5 will have a mapping, and then -5, x equals -5 will be in the domain bag, in the domain set. But what happened when we put a -5 into this equation, Griselda? We got -5 plus 5, which is what in the denominator?
0.
And what happens when you have 7 divided by 0, 10 divided by 0, -4 divided by 0? Does it equal any number?
No, sir. It's undefined.
There's no such defined number, or it doesn't exist. There is no number that exists, or we say undefined, yeah? Which is why right here we would say undefined. Which means what then, Griselda? Is -5, right here's -5, is there gonna have a mapping and be some number or no such number?
No such number. It doesn't have a mapping.
That's what, correct, very good. And that's why when we look at -5 right here on the x-axis, if we look up, it's never gonna have a mapping. And you might say, yeah, it is. Oops. You might say, yes, it is. Yes, it does. But look at right here. And we've talked about this before. Is this ever gonna, this green curve, is it ever gonna touch this line right here or just get closer and closer?
I'm sorry, repeat that again.
So do you think this green curve,
Oh,
you
it's
think,
not gonna touch.
no. Because why? At -5 is, does it negative x equal -5 have any defined mapping?
Nope.
No.
No define.
So that's why when we read this equation and they say, Griselda, what's the domain of this equation? And then you're supposed to say, oh, I see there's an x in the denominator. That means there's a possibility that we get something like this with a division of 0, and there won't be any mapping, there won't be any answer, and then we say there's no mapping, and thus the -5 won't be in the domain set. Does that make sense?
Yes, sir.
And when we get this happening like this with 7/0, -4/0, 10/0, yeah, that means you're going to get this kind of situation here where the graph gets closer and closer but never touches, which means it goes up forever and never touches. On one side, it could go up forever. On the other side, it could go up forever, or it could go down forever like this one. See over here? It goes down forever, but it also doesn't touch this line right here. Does that make sense?
Yes, sir.
And so what would we say, Griselda, is the domain of this set? We're going to say it's what? All x values. Well, it's a short way to write it. All x values except for which one?
-5.
Mm-hmm. How would we write it in interval notation?
I don't know. An open circle?
So,
An empty circle, I'm sorry.
so then almost what would be, don't all these x values here have mappings, Griselda?
Yes.
And what's forever this way then?
In negative infinity, we start with that open parentheses.
Now you remember, good. All the way until, where does it not have a mapping?
-5.
Yeah.
So we would put a closed bracket from there?
If we want to include it, do we want to say,
No,
oh, so close what?
parentheses.
Not close bracket, no. So, but that's not all.
We have
Comma.
a second.
What about when you pass -5? Are these numbers right here on the on the domain axis? Are they in the domain set?
Yes, sir.
So now we start up again and we say, oh, there's more.
We would
Starting
start with
where?
-5 again.
Good.
And to infinity.
Excellent. There you go.
And then close
Any questions there?
No, sir.
Okay. William, are you with us? I think we wore him out, Griselda. Yeah? Okay, so I'm going to clear all this. And we're going to go back. Oh, so then, Griselda, what do you think would happen on one more? And then it should be hopefully simple for us. What if we had 2 divided by x minus 3? And we want to know the domain of this function. So, domain. Well, if there's no division of with a variable x in the denominator, well then it might be all x values again, which would be negative infinity to infinity. Or unless there's a place where we get a division of 0. So is there any x value that we could put right in here, plug it into the formula, and then we get a division of 0 again? So what do you think, Griselda?
Wait, if we put a positive 3, it would equal 0 again. So
Very good. Perfect. If we put for x a positive 3, and then when we substitute it, we'll still have the 2, we'll still have the parenthesis, we'll still have subtraction of 3, but now we'll have this 3 right here. And that equals 2 divided by what?
by 0.
And does 2 divided by 0 equal anything, or no such number?
No such number, sir.
Yeah, no such defined number. Or what's another way to say no such defined number?
Undefined.
Yeah. And another one is does not exist. There's no number that exists, huh?
Correct.
So sometimes you see DNE does not exist, or you see undefined, and they just kind of shorten it up so they don't use so many words. But then sometimes when we're learning this and they shorten it up, then we're kind of lost. Yeah. So then how would we write this domain then, Griselda? And by the way, look at over here at x equals 3, 1, 2, 3. Don't we have this same behavior again where the graph's getting closer and closer to this line, but never will touch it?
Correct.
And you're like, yeah, it touches it right there. But if you zoom in, there's actually a gap, isn't there?
Yes.
A space, huh?
Yes, sir.
So what would we say is the domain of this set, Griselda?
It would start with the open parentheses on negative infinity. And from there, it would stop at negative 3. Or actually, if we're going, no, yeah, negative 3.
So
3, sorry.
3, very good. Close bracket, close parenthesis, which one?
Close parentheses.
Is that the only numbers that belong in the domain bag, the domain set, or are there more past 3?
There are more.
Yeah. So what else do we say? Comma.
Open parentheses 3, comma, infinity, and close parentheses.
Very good. And that's when they asked for the answer in interval notation, huh?
Yes.
Yeah. If someone just said, hey, it's all real numbers not equal to 3, that's also true. It's just a different way of stating the domain set, huh? Is that okay, Griselda?
Yes, sir.
This is more, well, this is when they ask us to write it in interval notation. Okay. So now we can go back to the homework problem. And I hope from this point on, it'll be really simple for us to find the domain here. So what about this one? The domain of f divided by g, which was this newly created function from dividing. And remember, we factored it x squared minus 9 was a difference of perfect squares, and we divided it.
Mm-hmm.
I mean, we factored it down
Factor.
to, yeah. And I said, I'll tell you why we factored it later. And if, and now it's later. So why do you think I wanted us to factor this now, Griselda?
So
'Cause
we
if
could
not-
get the answers to on interval notations.
There you go. How many parentheses do we have here, or factors that have an x in it this time? Not one, but how many?
2.
So then there's going to be how many places where we're going to get a division of 0?
2.
You think it's just one x number again, or 2 of them now?
No, just 2.
2 of them. So what numbers do you think we would put in and get this no such number again, or undefined, or does not exist? No such defined number, which means,
A positive 3 and a negative 3.
hey, there you go. Awesome. William, are you back with us now?
Yeah, sorry.
It's okay. Does that make sense to you, William?
Yes, it does.
So we're going to say at 3, because right here, 3 minus 3 will be 0. And if you put 3 here, 3 plus 3 is 6. But 6 times 0 from over here will still be 0 on the bottom. Yeah, and if you put a 3 right here, 7 times 3 is 21, plus 1, you would get 22. But in the denominator, you would get 3 minus 3, which is a 0. And I hope it's okay, I'm going a little faster here. And 3 plus 3 would be 6. But then, Griselda, what's the 0 times 6 going to be in the bottom?
0.
And then we get back to this, huh? So that's why 3 will not be in the domain set. And that also means at x equals 3, we're going to get that curve that either goes up, 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 and gets closer and closer, or it could go down this way, and the same thing on the other side. We would have to, we're not being asked to graph that right now. We're just being asked to know what is the domain set. But I hope we do know it's going to be something like that. It could go on the left, it could go up, 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 or it could go down, down, down. On the right, it could go up, 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 or down, down, down. Yeah? It just
Yes.
depends on all of this equation. So what are we going to, what's the other number that we're not going to get a mapping, which means we'll have another one of these situations right here. And by the way, there's a fancy word for this. That is called, this vertical line is it's called a vertical asymptote. And, or there's different ways we can phrase this, but the blue graph has a vertically asymptotic behavior at 3, because at 3, x equals 3, there's no defined mapping, which means the blue graph's gonna get closer and closer to this vertical line, this vertical asymptotic boundary line, x equals 3, which just means that this curve, again, there's more than one way to describe this phenomena right here, if you will. This curve starts to become straighter and straighter and straighter, and go up and up and up, although it never becomes perfectly straight, vertically straight, because if it did, it would have to, well, it's just never going to touch this vertical line right here. So it never quite becomes vertical, but it sure gets super close. And the same thing on the other side. Okay, so that's like the fancy formal language for that situation. So, well, there's one. Where else was there going to be no mapping? Where else are we going to have this kind of situation where the graph goes up or down and gets closer and closer to a vertical line or a vertical asymptotic boundary line? where else did we say? Well, whenever this other parenthesis factor here makes a 0 on the bottom. And where do we say this one was going to be?
-3, sir.
Mhm. And then we get no, so same thing here. If we did put a -3, we would get a slightly different computation here. We would get -7 times -3 is -21 plus 1. That's -20. And in the denominator, that's supposed to be a 20. -3 minus 3 is -6. But that's not the part we were really terribly interested in. We were looking at this part. -3 plus 3 is 0. And now we have -20 still divided by
0.
0. And that's when we get this no such defined number again, which means at -3, we're going to have another one of these vertical asymptotic behavior situations going on. And that means the blue graph is going to do a similar thing to what is over here. It's either going to go up, 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 closer and closer to this becoming more and more vertical like, but never touching this vertical line upward or downward. And same thing on the right side. It will either, like somewhere like this. This one was going up, maybe then the other side might be going up that way, or it could have gone down that way. We don't know unless we examine the graph further by graphing some points, or there's other ways as well. But we're not supposed to focus on that right now. So, so then what's the domain going to be then in interval notation? So when we're on this x domain axis, this x-axis, oh, that's not very good there. I'm sorry. But what will be the domain set if we know the only two places that there's no mapping is going to be at 3 and -3. So then what's the domain set going to be, Griselda?
Wouldn't it be like the other one? We go
Yep.
with the infinity, -infinity, comma, well, open parentheses, I'm sorry, and -infinity, comma, 3, and then the next one would be
3 or
+3.
-3?
I'm sorry, -3
Mm-hmm. And
for the
then
first one, and then the second one would be
close parenthesis, close bracket. What do we want right here?
close parentheses.
And then
Then the next one would start with +3. No, -3. -3, and then comma, infinity, close parentheses.
do we just go forever and or is there another place where there's no mapping?
3.
Ah, close bracket, close parenthesis,
Close parentheses.
and then what?
Also, there would be a third one. Then we start with open parentheses, +3, and then comma, infinity.
Yay, Griselda. You're getting good at this, Griselda. Does that make sense?
Yes, sir.
William?
Yes, sir.
Okay. So that's very powerful that if we can get this, I know it takes an hour or 2 hours, but that's kind of like an important deal there in mathematics, and many of us have trouble with that. So I hope, so that's good. So I'm going to type that, what you said. And we got it. Any questions there?
No, sir.
No.
So let's do letter D only. And that's the most interesting one. And that's the one that also will have a domain that's interesting for us to analyze. So I'm gonna say it's safe to assume that you guys could do the adding of the two functions, the subtracting, the multiplying. Let's just do the division one because that's the most interesting one. So William, what's going to happen when we divide f divided by g? We just write a fraction bar. And what goes in the numerator?
3x minus 7.
And the denominator?
2 minus x.
This is x to the first power, x to the first power. So those are linear factors, which means we cannot factor down anymore. So like the last one over here was x squared minus 9, and then we were able to factor them into two linear factors, the x plus 3x minus 3. But this one we can't. So what about, so that's what's going to go right here in letter D box, right here. But this is the more interesting part, the domain. So, so what would happen if we start to plot points, yeah? And we're cruising along the x-axis. All these x's are gonna be in the domain set unless there's a fraction in the equation that has a variable x in the bottom, which could maybe make the bottom into a 0. And then we have that no such number again. So William, would that ever happen? Is there any number we could put right here and then end up getting no such number, or no such defined number, because it's a division of 0 problem?
Yes, you could put 2 for x.
A 2 for x, very good. No such defined number. Is that okay, Griselda?
Yes, sir.
And so that's at 2. Because if you plug 2 in, we would get 3 times 2 is 6. 6 minus 7 is -1. But 2 minus 2 would be 0. And there we are again. And that's what this is. And that means there's no mapping. And there's no mapping at 2, which means we're going to get the graph again is going to be, we would have to explore more to know exactly which way it's going. And, but it's either going up, 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 up this way, or down, 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 down this way, and the same thing on the other side. Yeah. And we could do that, but it's not the focus of this section. Okay, so then what will be the domain set, William?
Would it be,
So all these x's on the domain axis will have mappings except for which one?
2?
So what's forever and ever and ever and ever this way?
Negative infinity?
And do we put a open bracket or an open parenthesis right here?
Open parenthesis.
Because you can't put a bracket, because if you put a bracket, open bracket, that would mean you could make it that there's like a place over here on the x-axis way out there that's negative infinity. But there is no place, is there? That's an idea that means forever, huh?
Yeah.
And then comma. So from negative infinity all the way, all of these x values have mappings, so they're in the domain set until which one?
2.
2. And then what do we put here? Close bracket, that would mean including 2. But if you put bracket, that means there's a mapping at 2. So which one?
Close parentheses.
Comma, is that it? Is
No.
that the only part of the domain axis that has mappings, or is there more?
There's more
Where?
after 2.
After 2. So from 2, and do we put open bracket here at 2 or open parenthesis?
Open parenthesis.
And then what? From 2,
Infinity.
and there is our domain set in interval notation. Any questions here?
Actually, for D, the answer would be -1/0, or
Oh, good question. So it depends. If they would have said this, because that's what some of the next problems are like. If they would have said, hey, F divided by G when you put -2 in, I'm sorry, not -2, 2 in, then that would be this question right here. What happens when you put x equals 2 into this equation, and then you would write no such defined number, but you would not, typically they're not going to ask you to put -1/0. They're going to ask you to say no such defined number, or they're going to say put does not exist, or they're going to say put undefined. Okay?
okay.
But on this one, did they actually ask us to put a number 2 in or any other number, or just write the equation down?
Just write the equation down.
So then we're going to write this one instead.
Oh, okay.
Does that answer your question?
Yes, sir. Thank you.
So now we're going to put that. So now when there's only one factor on the top and the bottom, and there's nothing else multiplied in front or anything, you don't have to put the parentheses. You certainly can. It's just up to us. But if we want to, we can, or not. Or put it on one of them and not the other one. It's okay too. And oh, and now this one.
It was negative open parentheses, -infinity, comma 2, close parentheses, and open parentheses 2, comma infinity, close parentheses.
Thank you. And check. And we are correct on both of them, okay? And I think you probably have a reasonably good chance to do these other 3 up on top. And they only ask, why are they only asking the domain on this one, on the division all the time? Because if you just have, if you don't divide, then there's nothing going to be in the denominator here. And then there's nothing interesting where you're going to have this no such defined number or this vertical asymptotic behavior. So that's why they're not even asking the domain on all of these. On what do you think the domain would be of all of these up here be then? If there's not going to be any one of these places where you have this no defined mapping, then what do you think will have to happen with the domain of all these other ones? So if you have an equation and it's y equals 2 minus x, then is there any division here with the fraction bar with an x underneath, with the variable underneath somewhere?
No, sir.
So then that means this can't never happen. That means if you make a table and you start putting x's in, you're never going to get this situation. This will never happen because there's no place that has an x in the bottom that could make a division of 0. So if that's the case, then this can never happen. And if it can't happen, then what's gonna be the domain then?
Infinity to infinity.
So from good. From
Negative infinity to positive infinity.
very good. Does that make sense?
Yes, sir.
So if they would, now here you would have to add these two together, but even when you add these two together, you're not going to get anything in the denominator. You're just going to get whatever these add up to. Yeah?
Yes.
So, okay, very good. Let's clear this out. And now that's exactly what they're doing here. So let's do one of these because here's this division. So let's do that. And then after this, that'll just take a few moments. And then there's one concept left, which is that composing. Okay. And so we're almost there. Okay. What about, how about, well, I don't know, any one of these. How about number 13? So they give us the two functions, f and g. They don't ask us to do all the basic 4 mathematical operations and add them together and subtract them and multiply them and divide them. They're only asking us to divide them. And then this is what William was asking about it right up above. Are they, but we could do this first. We could say f divided by g, or they write it however they wrote it above as well, or just like this, f over g, oh, sorry, f over g, and then of x. That would mean just write the equation down. But that does have that, which is equal to this, by the way, f of x divided by g of x. Let's do that first. And then we will decide, do we just leave the answer like that, or do they want us to put a number in for x? So Griselda, what are we gonna write on top for when we create this new function? It's gonna be what's supposed to go on the top?
X plus f, x plus 3.
And what else?
On the bottom will be g, so x squared minus 2.
So if they wanted to ask us the domain of this function, there is an x down here, isn't there?
Yes, sir.
And there would actually be two numbers where you would not, where this bottom would equal 0. It's just a little bit more interesting to figure out what they are. If they did ask the domain, then it would turn out that, without me taking very long, there would be two places here. And they would be when, so this one's kind of harder to see in your mind, because if you put a 2 or a 3 or a 0 and square it, subtract 2, you don't get 0. So what does happen is, so this is what we're going to be asked to do, sometime soon. Just figure out the domain here. So you just find out when is the bottom equal to 0, and because it's kind of hard to see it in your mind. So you move over the -2 by addition. How do you get rid of square? What's the inverse operation of squaring?
Square root.
Mm-hmm. So then we would write square root. And then we would write, I'm kind of going fast here, but plus or minus the square root of 2. So there would be two places. One of them would be positive square root of 2, and the other one would be negative square root of 2. And if you put that in your calculator, that would be like 1.414 something. And the same thing over here. There would be two places where on the x-axis where there's no mapping, and then we could write the domain just like we've done on the other problems. Except you would have 3 parentheses, 3 intervals from negative infinity to negative square root of 2, from negative square root of 2 to positive square root of 2, and then from square root of 2 to infinity, just like we did before. I know that's a little rushed, but I hope that's okay.
Yeah, that makes sense.
But that's not what they're asking. They're just asking for us, well, what are they asking? Do they just want this equation and we put it in this box?
No.
They want us to do what now with this equation? Okay, congratulations, we've created a new function. And it was created by taking f function and dividing it by the g function, and there it is. Congratulations. But that's not what they want us to put here, because now they're telling us, hey, well, let's go one more step and let's get a point. And what point did they just happen to pick?
5.
5. And maybe we'll get no such defined number, but that won't happen because the only places where there'll be no such defined number are these 2, which was something we just did extra. But anyway, so here we actually are going to get a defined number. So we just plug in 5 wherever there's an x. So we get the 5 plus 3. We get the 5 squared minus 2, and then we simplify. So we're going to sell the 5 plus 3 will be
8.
5 squared
25.
minus 2.
23.
8 doesn't go into 23, it goes into 24. And 8, you can break down 8 as like a 2, but 2 doesn't go into 23, so therefore this is already reduced. And we would put here 8 divided by 23. This would be the exact form unless they ask us to round it to the nearest 10th or 2 decimal places, whatever, but they don't say anything. So if they don't say anything, what do you think they want us to do? Do you think they want us to round it or write the exact fraction?
Exact fraction.
And we do that. And up here, and we're good. Any questions here?
No, sir.
No, sir.
Okay, so you do the same thing on this one. You might think, oh my gosh. By the way, it's the same equation. Oh, and it's x plus 3, just like up here, x squared minus 2, just like right here. It's still division. So we already have that part done. It's right here still. But what do they want us to put in this time? Not
0.
a 5, but a what?
0.
A 0. No problem. Well, since we already have it, we can do that in just a few seconds. So what's going to happen when we now put a different x value and they want us to put a 0 in? You might think, oh, we're going to get no such defined number, but no, because we already know that from this discussion, the only places where there'll be no such defined number was the square root of 2 and negative square root of 2. So at 0, we better get a defined number. So let's put 0 in. So instead of 5 plus 3 and 5 squared minus 2, we're going to have what, Griselda, up here?
No, negative 3. Oh, no, I'm sorry. 3 over negative 2.
Very good. 0, 0 squared. 0 plus 3 is 3. 0 times 0 is 0. 0 minus 2, negative 2. And we get this. Yeah. And now we put that right here. And it doesn't matter when you have a negative fraction where you write the negative. You can put it in the bottom, in the top, or out in front. And we are good. So let's not do these, but just talk about it. So what do you think this means right here? We're gonna do what? Put what? Well, there's two problems right here, actually. Well, let's see. What do you think this would mean up here, number 12? Let me just wipe this stuff out. So what do you think this would mean right here, William? This would mean do what? What's this part? William, are you there?
Oh, sorry, I was muted.
It's okay. My wife mutes me all the time. Okay. And she has a remote control, and that doesn't, it's not fair. But anyway, so what does this mean?
It means x plus 3 times x squared minus 2.
Good. So the new function f times g, which they don't even write the dot. And at first we would write it not with the x instead.
Mm-hmm.
And that would be, you just said it, x plus 3, which is f, and then g, x squared minus 2. And we could multiply all this out again, but we don't really have to because they didn't ask us for this reduced answer. They just asked us to do what with this? To plug in
7.
what? A 7, huh? So just put a 7 in. By the way, is there any division fraction bar with x's in the denominator, guys?
No.
So are we ever going to get a division of 0 on this?
No.
No.
It's impossible, huh? Because there's no fraction bar with x on the bottom. So what do you think the domain would be of this function, this new function we just created? Yeah, what do you think about on this domain axis? Do you think there would be any place where you would get that situation again of division of 0, which means no mapping? Would there be any place here or no place?
No place.
No place. Yeah. So what would be the domain of this function?
Negative infinity to infinity.
Very good. And that's when we start to get good at answering domain questions, which can cause people a lot of grief and they maybe never get it. But I hope that makes sense. Griselda, is that okay?
Yes, sir.
Okay, so now I'll put a 7 in and you're like, well, I want to multiply it out first. Well, we could. And then put the 7 in, but we would get the same answer as long as we didn't make a mistake as if we just leave it like this and compute it. It won't matter. It shouldn't matter, and it won't. So let's just do that for time's sake. So what's going to go right here for x, of course? It's going to be just a what?
7.
7. And this will be a 7 squared minus 2. And then we compute. So Griselda, the 7 plus 3 will be what?
10.
And these 7 squared,
49 minus 2
which good is what?
47.
And here's 47. And then is that it, Griselda?
No, we still have to multiply those together.
Good.
470.
Mm-hmm.
Oh, Lord.
So at x equals 7, this graph would go way, way up to 470, yeah? There would be a point way up there. And now we just put that here. Very good. Any questions here?
No, sir.
Okay, so these will be for you guys and your classmates. And just a comment, and then we have one last concept, which is the composition. So, what do you think? This one has multiple, it has more than one thing to do. One of the things we have to do is compute what? F of
6.
6. Well, what's that mean, William? We're supposed to do what? Take function f and do what to it?
Put a 6 and the x.
And what would that become? 6 plus 3 would be what?
9.
9. That would be the f of 6. I keep saying I'm not going to do it, and then I do it. Yeah. And then what about this part, Griselda? This means what right here? F what?
6. Oh, I'm sorry. Hold on.
Does it mean,
We have to put the 6 in the x on the g section. Or
so
wait,
is it a 6 or a 3 on this one?
the first one is a 3.
Yeah. So that means we're going to take f multiplied by g, by the way, which was what we were just looking at before as well, but so we're going to write f. What's f, Griselda?
The first one is 3.
But what's
Oh,
the,
no, x plus 3. I'm sorry.
no, it's okay. And the g is what?
X squared minus 2.
And then what are we going to put in this right here? What do they want us to put? A 6 or a 3?
A 6.
What's this part here say, Griselda? F times g, but put what number in?
Oh, 3.
So what are we going to put right here, Griselda, for x?
3
So it'll be 3 plus 3.
plus 3.
And what's going to go right here? The minus 2 still. And we're going to put,
6.
you just
6
like
squared.
that number 6, don't you, Griselda? Do you have 6 children?
No.
You have 6 houses, 6 pets, 6 husbands.
No.
No, I'm just kidding. So what are we going to put right here for x?
Still 3?
3. Yeah. Aren't we still doing this first part, Griselda?
Yes.
Oh,
I'm sorry. It's just that my son is trying to find it because he's about to go to speech therapy online. So
okay.
I'm getting distracted.
I'm sorry. And I keep taking forever here. What's 3 plus 3 now? 6. There's your 6, Griselda. That's what you've been wanting. Okay. 3 squared. Don't say 6, Griselda. What's 3 times 3?
3 times 3, 9.
Minus 2.
7.
And 6 times 7.
42.
Good. That took care of the first part. Plus f of 6, that was the other piece, which we already did. And that was plus 9. So 42 plus 9 is?
51.
And that's what goes right here. And we are correct. Any questions here?
No, sir.
No, sir.
Okay, last thing, and that is composition. This means composition, or composing. And so these questions down here are all composing. Well, except for this one. 22 is like we did at the very first, the very first problem, except the graphs are separate pictures instead of together. So, and Yeah. So composition. Okay. So okay, so I'm just looking for one that I like here. Okay, 19. So hang in there. Last thing. So this means now we got to talk about what in the heck is this compose. Oh, I want to change color here. How about blue? So compose, then G. Okay, now that doesn't mean foggy or fog, although my mind gets foggy, but it means the following. It means put the second function that's written after the little composing open circle, and we're going to put or substitute the G function into the whatever is written first. So that means, look right here, everyone. What, William, what is the G function? What does the G function happen to be?
X minus 4.
Mm-hmm. By the way, okay. So what if I wrote this crazy thing right here? Oh man, I don't know. Maybe that'll confuse you. But okay, we're good. So we're gonna put X minus 4, which is the second function right here, and we're gonna put it into which function? Well, whichever is written first. So we're gonna put it into what function? We're gonna put it into
The
F,
x squared.
which is right here, huh?
Yes.
So instead of X,
So we're plugging it in.
yep, we're gonna, instead of the X squared, we're gonna put G right here. And we get what? G what? G what?
X minus 4.
G squared. You're like, what the heck is that? G squared. Okay, so stay fresh here. So now you have to go one more step though. Well, Griselda, what is G? What's another way of, what's G specifically? Because we can have lots of equations that say G. This one says X plus 5. This one says G is X minus 4. And maybe there's all kinds of other ones up above and below and so forth. But what is G on this problem?
X minus 4.
Very good. And now we could multiply all this out. Doesn't it mean X minus 4 twice?
Yes.
Now we could write it like that, and they will give us credit. We could write it like this and then multiply it out, and they would give us credit. Or we can just leave it like this, and they will give us credit. So this one, multiplied out, and we would have a third answer. Any of these will be okay. So right here, we're gonna write X minus 4 quantity squared. And check. And where am I? Where are we? We are right here. And we are correct. Now that might have seemed strange, but it's really, I hope, even though we're getting tired, I hope you'll find it to be really quite nice. Now, what about this one? It's, let me just pick some colors here that, whatever. So let's say this one's blue and this one is whatever, brown. Oh, I just used brown. This one's F. And so G compose F. So G, and then we have F. And then we have the mathematical operation compose equals. This means, which one is written secondly, Griselda? G
F.
or F this time?
F.
And that means what? Put F into what function?
G.
G. So we look at G right here. And instead of x minus 4, what are we going to put right here instead of 4? Instead of x,
X
what are we going to
squared.
put? We're going to put what right here? F.
X squared.
You are correct. I can't keep up to you because you go so fast. Okay. I'm going to write F right there because that's what we're supposed to put in, aren't we?
Yes, sir.
And now you got ahead of me, which is good. And now let's rewrite it. So instead of x minus 4, we're going to put what there, Griselda? What is F?
X squared.
Very good. And you could factor this if you wanted to, but there's no need. We're not asked to find the domain. This was not in the denominator. They just want us to write down what is the new function we just created, and it is x squared minus 4. You don't need the parenthesis. You could write it, include the parenthesis, but either way. And we are correct. Any questions there?
No, sir.
William, you doing okay?
Yes, sir.
Okay, it's not too hard, is it?
It's quite easy.
Okay, good. So let's see. We could do, well, this looks strange. What does
Yeah.
this mean, William?
Put
Put G into what?
G.
Yeah. So let's do that one. So, okay. So let's see. We have G. So G, and well, they're both G's. So I guess I have the same color. And G again. And this equals, and this means put G into G. Well, G is x squared. So this is the, how about I highlight, I mean, I don't know if that helps or hurts, but so this one. So we have,
Wouldn't it be X minus 4?
oh, I'm looking at the wrong one. Yeah. So G is this right here. And we're going to write x minus 4, oops, x minus 4, but instead of x, we're gonna put in what function? Yeah, what function are we putting in? We're not putting in, not like these other two, but we're putting what? G, let's say I write this one as a orange G. We're putting this one into this one, aren't we?
Yes.
So right here is X, so we're gonna put G right there where the X is. That's a G. And now, instead, we still have this minus 4, but what are we gonna put right here instead of G? Well, what is G?
X squared minus 4.
No, not X squared.
I mean,
What's-
X minus 4, sorry.
Mhm. So you take the first function that's here, G, you write it down, X minus 4, but instead of X, you put whatever this one is that you're supposed to put inside. And isn't that a G right here? So instead of X minus 4, you put the G right where the X is. So now you have G minus 4. But what is G? It's X minus 4. It's just kind of strange because you're putting the same function into itself. So now clean it up. And what do we get here, of course? We get our brand new function. X minus 4 more is X minus what?
8.
8. And we're done. Any question? Oh, check. And we're good. That might have been a little strange, but hope it was okay, or at least relatively okay. We can practice one more. Any questions there?
No, sir.
No, sir.
Okay. Okay, number 20. And maybe we just, well, we'll see. That doesn't take very long. I know we're getting tired, or maybe I'm the only one getting tired. I don't know, you guys are young. So what's this one? So let's say we have F, we have G, and now we want to put G into F.
Oh.
So you write down this one, you write it down, and that is this one. That's I have a harder time with all the colors here, I think. So this is G, this is F, sorry. And so we start to write down what F is, which is the cube root of X minus 5. But instead of X right here, we put whatever is the second piece right here, which is the G, and we write it right here. So we just put G. Now, most authors or teachers will not write this step right here and put the G. I just like to do it because I think it helps people, but it's my opinion. And any questions on that part?
No, sir.
You're putting G into the first function here, the first function was cube root of x minus 5, but instead of the x, you put whatever was right here that you're supposed to put inside, g. And now, this is where maybe most authors, they will skip this step and then they'll just put g in, but they won't write letter g. They'll write what instead right here. So what is our g?
X cubed plus 5.
I just feel, my opinion, that this helps people. Yeah. So any questions there?
No, sir.
No.
Now clean anything up that we can. X cubed plus 5, there's only a invisible multiplication of 1 in front. That won't change anything. So we just get x cubed plus 5, still minus 5. And of course, what happens to the 5 minus 5?
Cancels
Cancel
out.
So now what's left? Cube root of what?
X cubed.
And if there's nothing else we can do, then we're done. But can this simplify somehow?
Yes.
Yeah, because what? You're putting the powering function of 3, or the cubing function, and you're putting it into the cube root function. And these are what of each other, these two functions?
Inverses.
Very good. So they compose out, and we get what? Oops.
Just
we get
X.
what? X. Okay. If these, I don't think they're going to do that to us, so I won't add any comments that you don't really need right now. So I'll just put X right there. And now what about this one? Well, any
Yeah.
questions? I think I already asked you. No questions there. Okay, now what about this one? G of F.
G X cubed plus 5.
So if you follow this, you're going to write G down first. What's G, Griselda?
X cubed plus 5.
But instead of writing X, you're going to put in whatever function you're supposed to put in, which is F, huh?
Yes, sir.
So if you want to use my suggestion and write this extra step to begin with, then I'm asking you guys to put what right here? What letter?
The F.
The F. Well, we're not going to leave it as F cubed plus 5. So now we continue. And what are we going to put right here then instead of F? What is F?
I don't know how to name the 3, the little 3 over the square root.
That's the cube root.
Oh, okay, so the cube
Or we
root,
can say the third root, either one.
third roots over X minus 5. I'm not sure if I read it correctly.
When you say that over, you just say the cube root, the third root of X minus 5. Any questions right there?
No, sir.
No.
Now clean it up if we can. Well, this is the cube root function is going into the cubing function, the powering function of 3, or we say the cubing function. And the cube root function and the cubing power function are inverses again, mathematical inverses. So they compose or cancel out. And what's left now inside?
X minus 5.
Mhm. And there's still this other plus 5.
So it would just be X at the end.
Mm-hmm.
Mm.
And we get X again. That does mean something. When you get X twice like that, it does mean something. I don't think it's necessarily the right moment to tell us, but we do look at that yet. But we kind of had a long day. Let's just leave it at that, since that's all we really need. And check. And one more. So G compose G.
Oh. Let's see.
So we write this one first. You're like, what do you mean they're the same one? But yeah, well, just think the same logic. You just look what this one is and you write it down. So what are we going to write down, William?
G cubed plus 5.
Very good. I'm just writing X for a little microsecond there. But now you put, instead of X, you put whatever was right here and we write it in there. So
Right.
G. Is that okay, Griselda?
Yes, sir.
And now do you think we're going to leave it as G cubed plus 5?
No.
So, no. Good. And we are going to write the plus 5 is still there. The cube is still there. But what are we going to put instead of G, the letter G, we just write down whatever it is. And what's G, William?
X cubed plus 5.
So the first time it's a little awkward and seems a little confusing when you put a function into itself, but I hope it's making sense now. Yeah. And now we're done unless we can clean this up. But this
Oh, wait.
does not compose out because this is a powering function, powering of 3, power 3, and there is no root 3 here anymore like it was up here. So this doesn't cancel out or anything. So we either leave our answer like this, or you could multiply x cubed plus 5 and write it down 3 times, and then multiply it all out and add 5, but there's no need for us to do that, okay? We can just leave it like that.
Oh, okay.
So we put
Would we have to put the parentheses, or we just put everything as is, x cubed plus 5 cubed plus 5?
you do need that parenthesis that I almost messed, I was beginning to write incorrectly, because the x cubed plus 5, all of that is to the 3rd power. So you do need to put all, because it's not just, x cubed is not just being cubed,
Oh.
but it's also the plus 5.
Mhm.
Yeah. And then here we have the other 5. Does that answer your question?
Yes, sir.
And we are correct. So you're going to do the same idea on 21 and on 18 and on 17. And I tried to pick the more interesting ones. So to help you versus the most simplistic one. And that brings us to one quick last question, which is any of 21 or 23 or 24, and then we call it a day. And let's just, how about this one, 24. And notice there are no equations that we are gonna plug G into F with the equation. We're gonna do it by looking at the graph. So I do feel obligated to help you with this and everyone else. So, and it's quick, so, okay. So let's say we call this one a blue one and this one a red one. So this one is the red one and this one is the blue one. I guess I could have graphed this and sketched it blue and this one brown, but anyway. So this is the same thing as F compose G and so so I'm trying to find words in my head here to make it sound as clean and consistent as we were before. Excuse me. So this means we're gonna put G into F, but we don't have any equations. They didn't give us the equations. So we can't write it like we did up above because we don't know what to write down because there's no equation given to us. So what we do then is this. They do tell us to do this at a X value. This is an X value. So what we do is I'm trying to find nice words, sorry. This means you're gonna put X equals 0 into, remember G is going into F. G is going into F. But we don't have an equation to write down. So we just can't write something and put the letter G into the equation wherever there were X's because we don't have that. So what all we can do is this, 2 steps. We're going to take the G and put it into F, yes, but we're gonna put G of 0 and put it into F. And almost done. And put it into F. Okay, so we're going to first figure out what G of 0 is. Whatever that is, we're gonna put it into F. This is the first step. And this, when you put it into F, that'll be the second step. Okay, well, let's do the first step. G of 0. We don't have an equation that we can go and substitute 0 into G and then work it out. But we do have the graph. So what we do is look at x equals 0, G of 0. That means when x is 0, put it into G, G of 0. That's the first step, G of 0. And now we write that right here, and that's our first step. So we look at G graph, and where x equals 0, the x-axis, the domain axis, we look at what x value? What x value are we being asked to find when x equals what?
0.
0 on the G graph, and we look for the mapping. So Griselda, what's the mapping on the G graph for our first step at x equals 0? What's the mapping? What's the range value?
4.
4. Good. So right here, we write 4. And that's the first step. That's this part. Okay. So this was our first step, and we got 4. This part is equal to 4. And now we take 4 and we do the second step, and we put it into what function?
To F.
F. So now the second step is to put the 4 into F. Which means now we're looking at the graph, the F function. This was the G. First step, second step. Now put 4 in. And now we put that, that's your F of 4. And we want to know what that is. So you look on the graph of F, and we look for the domain value 4. So that's 0, 1, 2, 3, 4. Here's 4. I think it got covered up here, or it's not showing. And now we look for that mapping. And Griselda, what happens at domain value x equals 4? What does it map to? What's the range value on the graph of F? It goes up to what?
4.
Just happens to be 4. Yeah, and that's okay. And we get 4. And then we're done. So here we put 4. And we check. And last one. Do this one. And I don't know if I want to clear all that yet. So let's do this one. And so we have F, and we have whatever, G, I. So we do this. So our first step is going to be, again, we don't have an equation, and we can put F into the equation G and have, because there's no equation. So all we can do is put the point in that they want us to, and then look at the graphs to answer this. So our first step is, William, what's our first step? To put 4 into G or put 4 into F? What's the first step?
4 into F.
Good. So 4 goes into this one first. put 4 in. And then we see what we get. So that's like saying, okay, I have a table and I have the F graph, the F equation, and I put a 4 in, and what does it map to? So we look at the F graph again, and at X equals what value? What value we want to look at what domain value here, William?
4.
And what does it map to?
4.
4. That doesn't help people because it's the same number, but we didn't write the problem. So, so this is 4. And then are we done then, William? That's it?
No, we still need second step.
So what's the second step? Take the answer we just got, which was what?
4.
4, which I wish they wouldn't have done that to us, but all right. And we're going to plug that into what function?
G.
G. Good. Into this one. Griselda, is that okay?
Yes, sir.
And now we look. So that's like, again, putting 4, put 4 into the G equation, and this is supposed to be a 4. And then what does it map to, which is the G of 4. So now we come over to which graph, William?
The
F
G.
or
Yeah. G.
G, and we look at what domain value,
4.
which is right here. We now want to put it in and look for the mapping, the range value. So what's the range value at X equals 4? Is it a positive number up here, a negative number down here, or what is it?
A 0.
0. Very good. So this is a 0, or we can say 0, and that's what goes right here. 0. Any questions there?
No, sir.
Griselda, you okay?
Yes.
And then check. And we are correct. So very good. And that should do it. Okay, so I hope we have worked hard enough here where you both and anyone else who watches this has a fair chance to do the rest of them, because we didn't skip anything here except different equations to practice it with. Okay, so very good. Any comments or questions before we stop?
No, sir.
No, thank you for your help today.
You're welcome. So don't forget, there's a quiz on 1.1 to 1.5 due, I can't remember right now. I'm tired, but I think it's tomorrow, but I'm not sure. Maybe it's the 28th or something. I don't remember now. But there's the quiz, there's section 1.6, which we covered last class. And now we have this one, 1.8. Next week on Tuesday, we will do 1.7. And yeah, so we'll leave it at that. And I hope this helps you all. So thanks for your patience and participating. And good luck with the homework and have a nice day. Tomorrow I'll have an office hour from 10:50 to 11:20 or 11:30 roughly. And if you guys have any questions, you're welcome to join. You can always email me as well. And so having said that, have a great day, everyone.
You too, sir. Thank you.
You're welcome. Okay, goodbye.
Bye.